So welcome everybody to another edition of Webinar Wednesday. It's so great to have you on board together for today. We're having a great discussion with some really good guests, and I'm looking forward to that discussion. Before we dive into that, I want to explore this particular question. What is it that makes a great engineer? You know, I spent 20 some years running manufacturing and technology companies, had the opportunities to work with some amazing people in the field of engineering. I also had an opportunity to work with some that weren't quite so amazing. What is it that makes those great engineers great? Well, for me, it was about five things. I start with the idea that we want people who were raised right. And what I mean by that is I want people who are dependable, people who come to work every day, people who stay off of drugs. It doesn't necessarily mean that they were raised right by their parents, but I want people that have a good head on their shoulders, who are conscientious, who care about other people and understand what it means to be a part of a team. That was always the first thing. The second thing was people who were comfortable in the gemba. Gemba is a Japanese word for in the action or where the action takes place. In Japan, they talk about the scene of the crime or a news story being in the gemba. In the world of manufacturing, the gemba is the shop floor. In the world of civil engineering, it may be out in the field, working on a project that relates to a bridge or to a road. But the point is, we want people that are comfortable working upfront and close with the technology that they're responsible for. The third thing I wanted was people who were big picture. I said here, every project has a price. In other words, just because something's a good idea doesn't mean that we can necessarily afford to do it or provide the return on investment necessary. So I like to have an engineering team that understood that we needed to have ROI, that we needed to pay back our projects, that we didn't have a blank check or an overflowing checkbook. And the second thing is every project has a deadline. In my years in the world of radio frequency identification, heading up engineering teams that were doing high-tech innovation in that space, we used to have a saying that the time comes in every project where we shoot the engineer and release the product. Eventually, we have to get done with the design, make sure that our product is as close to perfect as possible, and then put it in the marketplace. The fourth item is I wanted people who knew more than theory. We all agree that things like physics and calculus and chemistry and algebra are important in the world of engineering. There's no question that that is a key, those are key competencies we need our engineers to know, but we also want them to understand the technology that they're working on in a hands-on fashion. After all, most people in engineering are hands-on kinesthetic people. They learn that way. Let's put them in a place where they have an opportunity to be hands-on in their education pathway and when they get to the workplace. And finally, I wanted people who understood process and people, because the truth of the matter is that the smartest engineer on the planet, if they don't have an ability to communicate their ideas and interact with others, is going to struggle in the workplace. These were the five things that were important to me. Maybe other people have items that are more important to them, but when I was hiring people for my engineering teams, these were the types of people that I wanted on my team. And that is why I am so excited about our topic today, about an engineering program in the state of Wisconsin that is preparing students in exactly this fashion. And I'm really excited as well to welcome our two guests. Our first guest is Dr. John Caters. John is the founding dean of the College of Science, Engineering, and Technology at the University of Green Bay, where he has been since 1995, formerly as chair of Natural and Applied Sciences. He holds a bachelor's degree and a master's degree from the University of Wisconsin-Green Bay and a PhD in civil and environmental engineering from Marquette University. He's received numerous awards, most recently the 2020 American Society of Civil Engineers Wisconsin Engineer in Education Award and the 2020 Central States Water Environment Association Bill Boyle Outstanding Educator Award. Dr. Caters, it is a pleasure to have you on board today. Thank you so much for joining us.
Thanks, Matt.
And also joining us today is Dr. Caters' colleague, Dr. Jagdeep Thoda, who is the Associate Professor and Chair of Engineering and Engineering Technology at the University of Wisconsin-Green Bay. His research interests include experimental and computational finite element analysis of structures under severe loading conditions, such as explosions and projectile impacts, developing optimization codes for design improvements in structures, shock mitigation with emphasis on structures with bolted joints, and experimental characterizations of polymer composites, metallic, and new generation materials under normal and extreme environments. I know that Dr. Thoda is brilliant because I'm not even sure what all of that is, but those are his research interests. He holds a bachelor's degree from Bangalore University in India and master's and PhD degrees from the University of Nevada, all in mechanical engineering. Dr. Thoda, it's great to have you here with us today as well.
Thank you. Same here.
We're really looking forward to our discussion. And Dr. Caters, I'm going to begin with you. And as you and I have discussed, the University of Wisconsin-Green Bay is investing heavily in expanding its engineering program offerings. What prompted this significant investment?
Sure. Thanks, Matt. So UW-Green Bay has been seeking to add engineering programs for many decades, but there's always been resistance from other UW campuses that already offered engineering degrees. We've always had pre-engineering programs and taught courses in math, chemistry, physics, statics, dynamics, material science, but students then needed to transfer after about 2 years to another institution to complete their engineering degrees. Over the years, many students expressed a preference to stay at UW-Green Bay, and given the large manufacturing base in the region, it really made sense for UW-Green Bay to offer engineering and support these industries. So we've still got about 25% of our jobs in Northeast Wisconsin are manufacturing based. So about 8 years ago, we started with 3 engineering technology programs that were able to get approved. And based on the success of those programs, we've now added 2 engineering programs in mechanical and electrical engineering. The great thing about the programs here in Northeast Wisconsin, there's numerous career opportunities for our graduates, and students can also have the opportunity to complete internships locally while they earn their degrees, as well as participate in capstone and senior design projects with these local businesses and industries that have now been incredibly supportive of the program. So a lot of investment has actually come from these industry partners.
Fantastic. And what a great way to keep your students engaged, keep them in Northeastern Wisconsin. I've spent plenty of time up there. Certainly manufacturing is the lifeblood in so many ways of that region of the state of Wisconsin. So this has really been a really important initiative for that region and for preparing those students, preparing those learners for great careers in manufacturing, and also inspiring that next generation of STEM and engineering talent. Now, I know the Brown County STEM Center is a collaborative project that will provide STEM experiences for Green Bay students as well as others in your community. What can you tell us about that project?
Yeah, this is really a remarkable project that brought many local partners together for a common cause. So partners in the STEM Center include Brown County Land and Water Conservation, UW Extension, the Einstein Project, and also the Richard J. Resch School of Engineering. The project's really unique, and even though it's located on the UW Green Bay campus, Brown County actually owns the building and then leases the space in the building to the tenants. This was done really as a way to significantly shorten the approval and construction timeline for the project. So in a lot of cases, it can take up to 10 years to get a project done through UW system. In this case, we were able to get it done in less than 2 years, actually. So the $15 million for the building includes $5 million from the state, $5 million from Brown County, and $5 million from private donors. And really the ideas of having these diverse partners in one location is about creating a culture of innovation and a pipeline of students interested in STEM programs. So several of the partners in the building offer programming for younger kids, curricular materials for STEM education, training to teachers, and other related activities that really stimulate interest in STEM. And so having the Resch School of Engineering in the STEM Innovation Center really allows our students and faculty to get involved in these activities with the other partners, while also providing inspiration to younger kids that these types of careers are attainable for them. This really aligns very well with the mission of UW Green Bay, which is positioning itself as an access institution, with student success being our #1 goal. And longer term, we're really looking to establish Phoenix Innovation Park, which would be adjacent to the STEM Innovation Center, which would bring more businesses to our beautiful campus with about 60 acres available for Phoenix Innovation Park.
So as our audience can see, the facility is absolutely stunning, absolutely beautiful. And it's been a great partnership clearly through not just the university, but other elements of your economy up there in Northeast Wisconsin. Just an absolutely beautiful result of all that hard work and that planning and that vision on your behalf, certainly Dr. Caters, and on the behalf of others. I know a big part of that vision was creating really fantastic interactive engineering labs. And as we turn our attention to Dr. Thoda, I'd be interested if you would be willing to take us on a virtual walkthrough of these engineering labs. I'm going to scroll a number of videos here of your labs there, Dr. Thoda, and if you could tell our audience what they're seeing and what they will see when they come visit your labs up there in Green Bay, that would be fantastic.
Yeah, we have totally five mechanical engineering labs in 4 locations within the STEM center. So I'm going to quickly walk through those 5 different labs. The first one is known as the Mechanics of Materials Lab. In this, students test common engineering materials like steel, aluminum, copper, brass for the mechanical properties. The second lab is known as a Measurements Lab. So as a mechanical engineer, students are going to come across huge machinery, and most of this machinery is going to have some type of sensors or instrumentation involved in it. So in this measurements lab, students are introduced to these common engineering sensors and measuring instruments. For example, like a load sensor, which measures a load, or a transducer, which can measure a displacement, and so on. So students not only get introduced to the sensors, but also learn the function of how they work. Then next is the fluids lab. In the fluids lab, students study the flow of fluids basically. So what this means is students look at how fluid energy can be converted to mechanical energy. So just to use one example, you can look at the pump. Pump is nothing but where you take the motion of the fluid and convert that to mechanical energy. So that's one of the applications they do in the fluids lab. Then we have the thermal lab. In the thermal lab, students look at the relationship between how heat or temperature can be converted to mechanical energy. One very common example of this is an engine in an automobile, where the heat in the engine can be converted to mechanical work which drives the automobile. And finally, we have the controls lab. So nowadays, with automation in the industry, most of the machinery are going to need to be automated, or most of the industrial processes need to be automated. So in the controls lab, students look at how they can automate most of the industrial applications or processes. Part of this is also robotics, where basically you try to control some functioning of the machinery or functioning of the process by automated or by computers. So overall, these is the gist of our laboratory experience students go under here.
Excellent. And, I can tell you, Dr. Thoda, as somebody who spent a career in manufacturing, when I hear things like sensors and thermal technology and fluids and robotics and certainly mechanics and materials, control systems, I mean, as our audience knows, that is the fundamental technology that your students are going to be working with when they get to industry. And I know preparing them for those opportunities in industry and partnering with your regional employers is such an important part of the work that you're doing at the University of Wisconsin Green Bay. I'd be interested if you could share with us, how do these hands-on experiences in the labs apply to the career opportunities that your students are seeing with your regional employers?
Yeah, I mean, the application of mechanical engineering is very broad, but just to make sure it's a short time frame I have, I'll just give one example. So everybody who's familiar with Green Bay know that the the paper and the packaging industry is predominant in Green Bay. So most of this industry in paper and packaging, they have huge machineries involved in those companies. So something like a machinery in a paper packaging or a paper producing, you need to go through different aspects of the labs that I just mentioned. For example, if you're going to be looking at a huge machine, like you just mentioned, there's going to be sensors in them. So students have to know the sensors so that they can design those products using those machinery. Same time, this machinery is also will be operating at different temperatures, and they might be dissipating a lot of heat. So we need to make sure the components are not damaged due to this. So they use the fluids and the thermal lab concepts to make sure the heat is properly dissipated and doesn't damage this equipment. And at the same time, in order to design this huge machine, they need to know some information on the properties of the materials such that they can withstand the loads the machine is going to be subjected to. So the mechanics of materials lab helps them to make sure what properties this machine's materials are made up of and how they can be used. And finally, with the controls lab, like I mentioned, recently with the Industry 4.0, we're looking at a lot of industry going automated, which a small number of labor force and everything being computerized. So the controls lab basically gives the students experience of how to design these processes automatically with the less usage of labor force.
And I love the smiles on your students' faces and on your face as they're using that equipment and learning those incredibly industrially relevant skills and competencies that you just shared with us. What a great way of preparing that next generation of engineering talent in a hands-on fashion where they're interacting, as we said in the introduction, directly with the technology that they will be using in industry. I know your team was incredibly proud to be part of the event when some of these videos were made. I saw a couple of members of the Lab Midwest team in those videos as well. And I know we were equally as proud to be a part of all the great work that your team has been doing. Now, as people might imagine, some of these videos were taken right before COVID or not long before COVID started. And then, of course, as this slide tells us, the world is temporarily closed. We lived through this era where we weren't able to educate our students quite in the way that we had been able to before. So I would be interested, Dr. Thode, in what strategies you deployed in the year 2020 to provide lab experiences to your students during COVID, in spite of the fact that maybe they couldn't be front and center with all the technology the way that you wish they could.
Yeah, this was a challenging experience, as anybody in academics would recognize. So we at UW Green Bay try to be as flexible as possible for the students. So we did most of our labs in a hybrid mode, where students who still want to have that in-person experience, we did give that in-person experience, but at the same time, we made sure that we followed all the safety protocols like social distancing, masking, and sanitizing the work areas before and after the experiments. But we also realized that there were quite a strong amount of students who might not be available to do in-person lab experience, either because they've come in contact with somebody with COVID and they have to go to isolation or quarantine, or just that they might have family members who are much more vulnerable and they don't want to put themselves in a bad situation. So what we did for such type of students is we did make videos of the lab experiments, or faculty conducted the lab experiments. We took videos of this. And then here at UW Green Bay, we have a learning management tool known as Canvas. So we uploaded these videos with the raw experimental data into the Canvas. So the students were able to access this video and the raw data for the experiment. But in order for them to access this, first they have to do a small quiz. So it's a very simple quiz, but in order to answer the question of the quiz, they have to go to the lab manual. So we made sure that the students still go to the lab manual, read the procedure and everything, answer the quiz, and then they can have access to these videos and the raw data. Then they took the raw data and calculated the results and did the lab reports. So even though most of it is virtual, we made sure as much as possible they got some lab experience from this type of arrangement with the students.
So certainly a tremendous amount of creativity went into creating those experiences for your students. Of course, that hands-on and interactive learning still so very important for an engineering student, in spite of the fact that we maybe couldn't deliver it the way that we always could. Of course, many of us, all of us, I think, are looking forward to getting back into that day where we can be fully engaged with our equipment and get away from some of the challenges that COVID-19 brought about in the world of education. But it sounds like you and your team, Dr. Thode, did a tremendous job of creating those experiences for your students in spite of the world that we were living in. So given the world that we're living in and some of the transition that's taking place in the world of education, I want to turn our sights now to Dr. Caters and talk a little bit about how education is evolving. And I think in the past, we maybe saw different pathways of students leaving high school, going direct to workforce, going to technical college, going to a four-year university. Today, we're seeing, are we not, a lot more integration and a lot more cooperation among our technical and community colleges and our four-year universities and beyond. So Dr. Caters, I'd be interested in your thoughts on how UW Green Bay is leveraging partnerships with your regional technical colleges to provide learning opportunities for your students.
Yeah, that's absolutely correct, Matt. So we consider NWTC, our local technical college, to be our most important partner. They offer a large number of high-quality associate degrees in engineering-related areas, and we've developed a number of articulation agreements that allow for easy transfer of their students into our engineering technology and engineering programs, while noting that in the first few years of this program, about 40% of our students were transfer students and about 60% were more traditional students. It should also be noted that because there were previously limited opportunities to complete a four-year engineering degree in the region, many people had good paying jobs in industry, but were really not able to easily continue their education beyond the associate degree. So going forward, we really expect that non-traditional students are going to continue to be a significant part of our enrollment in these programs as they seek additional education and career advancement opportunities. And similarly, we've got articulation agreements with other technical college schools as well, with Lakeshore Technical College being another one. And they've actually become part of our territory now. So we had a merger within UW system, and we now have 4 campuses, with one being in Sheboygan and one being in Manitowoc, and Lakeshore Technical College sits right in the middle. And actually, as a matter of fact, we had our semester meeting this morning with NWTC, which we call Crossing the Bridge. So one of us is on the west side of town, one's on the east side of town. And we pulled together a large group of administrative staff to try and break down as many barriers as we possibly can to allow students that easy access to our campus after they leave the tech college.
And that's so very important. And certainly we here at Webinar Wednesday know very well both NWTC and LTC, both great institutions doing great things for their students. And that creativity on the part of UW Green Bay in building out those partnerships, creating those articulation agreements, creating as many pathways for those students as possible, we know, first of all, are certainly going to serve those students, giving them all those great options and opportunities, but are also going to serve the industrial employers. And we know that those partnerships are so very important. Now, Dr. Caters commented on this a couple times during some previous questions about the value of those industrial partnerships. I would be interested, Dr. Thoda, in your thoughts on how those industrial partnerships create learning opportunities for your students. Do your engineering students get real world work experience as a result of those partnerships with your industrial employers?
Yeah, it's a very good question. So I'll answer this by giving 2 examples because of the short time we have. So just before COVID, we had this class known as mechatronics. Now, mechatronics is a combination of concepts in mechanical and electrical engineering, where they combine this to basically apply to control any system. So for this class, there's a project requirement, and we got in touch with a company known as Wild Blue. It's a local company, it's a design company. And they had this product, it's a very exciting product, which was lying in their shelf for a couple of years because they didn't have the resources dedicated to somebody to work on it. So our students took up this project, and they created like a control system to operate this particular mechanism which they had. And this was like basically a live real world experience they got by taking a class as mechatronics from our mechanical engineering. So that's one example I've got right there. The second one is, as I think in earlier discussion, we talked about the capstone project. So all our mechanical engineering students, before they graduate, they have to take a class known as senior design, which is a capstone project experience. So currently we are offering that class this very semester, and all the students in that class are actually working on live projects from a company known as Infinity Machines. So Infinity Machines is again a local Green Bay company. They are a worldwide leader in paper packaging. So our students are actually designing and trying to assemble machinery for paper packaging. So there's a live project they're currently doing and getting this experience from. So this is just 2 examples I'm giving, but we do have many more like that. So this is our objective. Main objective is to provide this aspect to the students for us in UW Green Bay.
And credit to you and to the program for providing those types of experiences for your students. As we said in the intro, understanding this technology, working hands-on, understanding what it's like to work, whether it's manufacturing, industry, any other environment in the Gemba, that's so very important. And it sounds like you're doing exactly that for your students and building these partnerships with your local employers. And they're getting a great opportunity to tee themselves up for success once they leave the program. And that's exactly what is starting to happen, is it not, Dr. Caters? The program has graduated its first 6 manufacturing engineering students. Tell us about the growth and the enrollment and the interest in at least in the short term of this program as you've had it available.
Right, so we did graduate our first 6 mechanical engineering students, and interest in the mechanical engineering program has been incredibly strong, far exceeding our enrollment projections when the program was established in 2018. We have seen a transition of some students from mechanical engineering technology into mechanical engineering, but the total number of students in the 2 programs combined continues to grow very rapidly. And I think at some point we'll see a transition back where some students go from mechanical engineering back into mechanical engineering technology based on their interests. So based on the success of the mechanical engineering program, we're also going to be starting an electrical engineering program in the fall of 2021. To support that program, a $5.7 million renovation project is going to be starting in a few weeks, and it's expected to be completed in time for the spring semester of 2022. This will add 4 labs for the electrical engineering and electrical engineering technology programs, new labs for physics, and also a space for a senior design projects area. And I would also add that interest from business and industry has been incredibly strong for electrical engineering, and they continue to just be very supportive of everything that we're doing as a university.
And that's just so impressive and so important, those partnerships that are so core to all the great work that you're doing at the University of Wisconsin Green Bay. I think that gives us a good sense for what's coming in the short term, and certainly expanding into other disciplines of engineering, providing your students and your community with even more opportunity, and your industrial employers and others with a pipeline of really, really solid talent. Is there anything else you'd like to share, Dr. Caters, on the long-term plans for expansion and growth, both in the region and extending to the rest of the state of Wisconsin?
Sure. As I mentioned previously, about the same time the Rush School of Engineering was formed, we actually added 3 additional locations to UW Green Bay. So we've now got campuses that go from Marinette all the way down to Sheboygan. And so our footprint as a university is now about 16 counties total. For those not from Wisconsin, that's about a fourth of the state. We've got 72 counties total. And so we're really looking at expanding engineering programs to some of these other campuses as well. So electrical engineering technology will be expanded up into the Marinette region. They've got a huge shipbuilding operation up there. They've got some major contracts that they've been able to get in the last couple of years, and they're going to be growing very rapidly. And then we're also going to be expanding to the south to the Sheboygan campus and adding mechanical engineering down there. And then once the electrical engineering program is fully established on the Green Bay campus, we anticipate rolling out electrical engineering at that location as well. So again, really excited to provide more engineering graduates to the region. Again, that's really the goal. Again, particularly as I mentioned earlier, when 25% of our jobs are still, manufacturing related, it's just important that we continue to provide this talent to our local businesses and industries.
Without question. And I might add, those 16 counties are some of the most beautiful counties in the state of Wisconsin. I've been as recently as the last couple of weeks in places like Marinette and Sheboygan, Manitowoc, Green Bay. For those people that aren't familiar with that area, absolutely beautiful. And what a great opportunity for those students who grew up in that area to be able to make a life in that area and continue to enjoy that natural beauty and all of the employment opportunities that exist for them as they move forward with their education pathway. We're having a great discussion with Dr. John Caters and Dr. Jagadeep Thoda of the University of Wisconsin Green Bay today on Webinar Wednesday. Melissa, I'm interested to hear what questions are rolling in from the audience.
Thanks, Matt. And again, to our audience, if you do have any questions, you can use that Q&A box to submit them. First question, can you explain the difference between an engineering program and an engineering technology program?
Yeah, I'll take a shot at that. So I put it as 2 main differences. One is the math requirement. So for engineering technology, both the engineering technology and engineering, you do need to have a minimum calculus level math. Whereas with engineering technology, you take 2 years of calculus. In engineering, you go beyond 2 years of calculus. You take additional 3 math classes. So that's one big difference there in terms of the curriculum. In terms of how the courses are being offered, the engineering technology are slightly more tailored towards the industrial aspect of the topics, whereas engineering is much more traditional engineering, which you'll see in most of the universities. So I would say engineering technology is more in particular to what industry we have locally in Green Bay, and some classes are more tailored toward that aspect of it. In terms of jobs, I would say is if you're an engineer or engineering technology, you do get the same opportunities, except maybe in the research field, where if you're looking for jobs, especially in the research field, there might be emphasis for engineering rather than engineering technology.
Great. And on the topic of jobs too, can you tell us what, I think you mentioned packaging, but what are some of the specific types of jobs that, your students are going to go out and get once they're done with your program?
Yeah, I'll just start off and maybe John can add on too. So mainly with electrical and mechanical engineering technology we have, manufacturing industry is the leading career opportunity for our students. And most of our students already got some type of internship opportunities, and some of them have turned into actually jobs. Some of these companies are like PCMC, Georgia Pacific, KI. So these are all multinational big companies, and students have gone on internships there, and most of them also turn into full-time jobs. So I just gave a few of them, but John, if you can add some more, feel free.
Yeah, Jagadeep's absolutely right. You know, these companies are companies that have supported their program. You know, they participate on our advisory boards, and you know, the internships is really the first gateway to them experiencing the quality of our students, given that we're a relatively new program. So we've been very pleased with how our students have been able to, you know, notably jump in with these organizations and provide, you know, a great amount of productivity to these companies right away.
Excellent. Thank you. Matt, I'll leave it to you to wrap up.
Thank you, Melissa. What a great discussion we've had on this topic of what one university, that being the University of Wisconsin-Green Bay, is doing to meet regional demand for engineers. We've talked about labs. We've talked about the experiences these students are having, the internships, the capstone projects, certainly the impetus and the inspiration for building the lab and building the program in the first place. Just a fantastic discussion. I want to thank our guests, Dr. Jagadeep Thoda of the University of Wisconsin-Green Bay and Dr. John Caters of that same institution for providing all of these fantastic insights. And as always, thank you to our producer, Melissa Martin, who did yet another great job of producing this episode of Webinar Wednesday. We are here every single Wednesday at 2 p.m. Central. Next week, we will be talking about a combination 3D printer and CNC machine with a FANUC control. For those of you that are in additive manufacturing, for those of you that are in CNC, you won't want to miss it. We'll see you next week at 2 p.m. on Wednesday.
Thank you.